Okay, this is exercise 2C, question 5. Let's just look in the book. So it's this one. It's a reasonably tricky question. We've got this quadratic equation. One root is 2 more than the other. So the way we can express that, we could say we have 2 roots. It's not, here we go. I've got 2 roots. Let's call one of them alpha. The other one is 2 more than the other. Okay? Now we know that the sum of the roots is, or would be, alpha plus 2. All right. Now that's just going to be 2 alpha plus 2. And we know that that's minus b on a. So what's minus b on a? It is minus b would be minus k minus 8. So that's the same as 8 minus k. A minus k and a minus minus 8. 8 minus k on a. Right. Now the product of the roots. So that will be alpha times alpha plus 2. That would be alpha squared plus 2 alpha. Alpha squared plus 2 alpha. I'm just wondering, is it better to leave it factorized or expand it? I've chosen to expand it because I'm not entirely sure. Anyway, the product of the roots is c on a. There's my c. 1 minus k divide k. 1 minus k on k. All right. So we've got alphas and we've got k's. 2 variables, 2 equations. It's like equation 1 here, equation 2. We need to rearrange. I'm going to choose this one. I think it will be easier. So if I work on equation 1, right, so equation 1, I could say 2 alpha equals 8 minus k on k minus 2. So I have minus 2 from both sides. I could also divide by 2. Divide everything by 2. Let's do that. Alpha equals 8 minus k divide by 2. And we have to divide that by 2 as well. Minus 1. Suppose we could substitute that in. But let's make it all one fraction. So we have alpha equals 8 minus k minus 2k on 2k. So that 1 is 2k on 2k, right? To give it the common denominator. So we end up with 8 minus 3k. Okay, we are now going to substitute 1, right, which is still here. It's the same equation, I've just reworked it, into 2. So I'll go up here. You should be working down your page. It's just that I've got this awkward pen and not a lot of space. So everywhere I see an alpha, I'm going to now make it a 8 minus 3k on 2k. So I've got 8 minus 3k on 2k squared. That's this bit here. and I've got a 2 alpha plus 2 alpha Now I'm going to do something here that I'm seeing. So we've got a times 2 and we've got a divide 2. They would cancel out to make a 1. So what we could do, hang on a minute, I forgot the k. Yeah, so 2 times, where is it? This one here. We got 2 times this. So we'd end up with 2, yeah, okay. So I'm going to rewrite that just mostly because I have a lack of space. Right. So we get 8 minus 3k on k after it's been times by 2. And that equals 1 minus k on k. Right. From here, maybe we could square this, and what about if we minus that from both sides? I can see this common denominator of k here. Alright, so anyway, let's square this as well. So we've got 64 minus, so what's the 2ab term? 8 times 3 is 24. 24 times 2 is 48. And then we've got this term squared plus 9k squared. Right. You have to square the top, you have to square the bottom. 4k squared equals 1 minus k on k minus, so I'm minusing this term from both sides, 8 minus 3k on k. Now in here, we have to minus everything, right? And we've got the same denominator. So let's see if we can rework that. Again, lack of space. If I was you, I'd do this on a separate line just to try and avoid making mistakes. We've got 1 minus k minus the 8 and minus the minus 3k. Minus minus, right? Which ends up being plus. So that turns into 2k minus 7. That's 2k, right? We've got a minus k and a 3k, that'll make 2k. We've got a 1 minus 8, it's minus 7. So it's ended up being 2k minus 7. Alright, at this point, I'm going to multiply both sides by k. I can see k's here and here. Right. This question actually did say k can't be 0, which is nice, because if it was 0 there, that might be a problem. We're going to come in, we're going to multiply that by k, and we'll multiply this by k so that I can do some cancelling there, and this will turn into a 1. Right. So we're going to get, next step, 64 minus 48k plus 9k squared on 4k equals 2k minus 7. We're going to multiply both sides by 4k. 64 minus 48k plus 9k squared equals 4k times 2k, 8k squared, and 4k times minus 7, it's minus 28, minus, so 4 7s are minus 28, okay. Alright, let's make it all equal to 0. So we get 9k squared minus 8k squared. So I'm just reordering things so they look like a regular quadratic. So I've got 9k and minus 8k squared. I've got a minus 48k. I've also got, I need to add 28k to both sides. And I've got the 64 as well. Then it equals 0 and it's a quadratic I can solve. Now I'm going to tidy it up. The 9 minus the 8 will just be a single k squared. Let's write that in. And the minus 48 plus the 28 leaves minus 20. Minus 20. Okay, we've still got our 64. All right, this is a quadratic I can factorize. 64, factors of 64, you know 8 times 8, but also 16 times 4. Right? So if I'm looking at two numbers that have a product of 64 and that could sum to equal 20, I could use 16 and 4. Right? So k minus 16, k minus 4 equals 0, right? So does that work? Yeah, look, there's your 64. You've got a minus 4k, you've got a minus 16k, that makes you 20, right? So therefore, after all of that, it seemed quite epic. K could be a 4 or it could be a 16, right? Alrighty then. That's unfortunately, these questions seem fairly long in the evening. That's only half the answer really, because it does want to know what are the actual roots, and I think the easiest way is to use quadratic formula because that's what it's finding. So we have two quadratics. Quadratic 1 is, let's use the 4. 4x squared. So I'm making all my k's 4s. And I'd have 4 minus 8x. That's a minus 4x. Then I'd have 1 minus 4. That's a minus 3 equals 0. And quadratic 2, I'm going to use the 16. 16x squared. We've got 16 minus 8 is 8. And we have 1 minus 16, that's a minus 15. These are non-monic quadratics. They're not going to be straightforward. Although this one, I think, that one there you can actually split the middle term. I'm not so sure about that one. I think I'd be going to quadratic formula or using the calculator. This one here, I think we can do this. So I've just split the middle term up for this one. 2x minus 3 plus 1. 2x minus 3 equals 0. Common factor of 2x minus 3. 2x plus 1 equals 0. Therefore, x is 3 on 2, or minus a half. So those are the roots for quadratic 1. For quadratic 2, I think I would be using quadratic formula. Minus 8, and I would be reaching for my calculator. So you know about the quadratic formula. I'm not going to actually solve all of this. Right, so I could leave you to figure that out. Just realize there is two roots there, the plus and the minus, and you could solve that. Okay,